In this demo, we're going to demonstrate Geomagic for Solidworks, and we're going to do it on this part here, which is a cast steel part. And we've already 3D scanned the part. You can get a look at it. It's got some decent amount of complexity on it, but this is a perfect part for the Geomagic for SolidWorks software. Now, what is the Geomagic for Solid software? It is a reverse engineering tool that runs right inside SolidWorks. So the real advantage of this software is it's very easy to learn and use if you already know SolidWorks. As you're going to see in this demo, there's really only a handful of commands that you really need to learn to be able to model from 3D scan data, because SolidWorks does not allow you to import an STL file and really do much with it, and that's why you need an extension like the Geomagic for SolidWorks, or add on it. Now, full disclosure, I am not a SolidWorks expert, so if you see me doing things in SolidWorks that you think could be done easier, better, faster, please understand it's not the native CAD system I know, and I've just kind of self-taught myself enough to show the concept of how it works. So we're going to get started, and we're going to walk you through, and we're going to go ahead and reverse engineer this part. All right, so to get started, you just open up SolidWorks like you normally would. And in this instant, we're just going to create a part. And once we have SolidWorks open, you'll see a tab that says Geomagic for SolidWorks once you've installed the software. And it's your typical ribbon style. The only thing available right now is the import. We're going to import our scan data, which is an STL file. The file is in millimeters, so we'll bring it in millimeters. And basically, this is STL data. So scan data is either points or polygons, and in this case, it's polygons. And the first thing you're going to notice is it's not in an orientation where you have a top, side, right type view. It's just kind of in some weird orientation because 3D scanners don't know what that is. So the first thing we're going to do to help us out is create what we call regions. And what regions do is just color code the scan data, because there is no CAD here yet. This is just a polygon mesh. You really can't do much with it. So by asking it to look at the scan data and basically color code it by geometry. So it's going to look for planes, cylinders, cones, spheres, and just color code that STL data. And that's going to help us extract geometry from it. But again, this is not geometry right now. It's just color coding the scan data. So we've set that. And now what we're going to do is extract some planes or lines or whatever, in this case planes, so we can actually put the part in a coordinate system. So you can see I've picked that region group, and we're just going to look at it and say okay, and it's going to best fit a plane right through that area I picked. Now we're going to go ahead and do the same thing for this side over here. I accidentally selected the wrong thing. I want to extract a plane. I don't need to create a region again. So pick that plane, hit OK, and you can see we've extracted a second plane. And for this part, that's really all we need to get it into a coordinate. You could also do an origin point. You can do a point, a line, multiple, or a plane, a point, a line. You can do all different ways, but all we really need. And now we're going to tell it we want to orient it, and we'll pick plane as our selection, and for the X and then the Y. And then we hit OK, and it's going to use that information to rotate the scan data, as you see here. And now when we go to a top or a side or a right view, you can see what we're going to get. Okay. So if we pick there we go. So it's you really want to be working in a coordinate system, because that's normally the way you work. But scan data never comes into a normal coordinate system, because when you start scanning, it just doesn't know unless you've predefined a coordinate system ahead of time, which most people don't do. Okay, so now we're looking at it and trying to determine, what is the best method to kind of model this, because we're going to model this just like you model anything in SolidWorks. So we're kind of looking at the features, and it makes sense to kind of make the big basic profile and then chip away at it at these different cutouts like you see here. So we're running the cross-section command, And before we actually run that, because those two planes we created they don't go with the part as it rotates, we're going to need to create a new plane. So we're going to go back into our reference geometry, and we'll use, again, the region group. We'll pick and we'll reestablish a plane at the bottom. And that's going to be kind of our main plane that we're going to start working with. And once we have that, now we're going to go ahead and cut our cross section through the scan data at that plane. The problem is when we offset this, so what it's going to do is it's actually going to cut a reference sketch, or really construction geometry, through the scan data. So let's adjust this. Let's try 0.05. So we actually want to cut down from our plane. We don't want to try to cut right at the plane, because we want to kind of sample that scan data just below that radius, as you see here. But the only issue we have is that's only going to get kind of the one profile there, and we really want all of these so we can kind of build our main sketch and then extrude our body. So the best way to handle this in here is to cut multiple sections and then kind of use them. So we're going to come in here and we're going to tell it we want to create 5 sections, and we're going to want to space those out. Let's take a look here. Let's try 0.1, and this will take a sec because it's got to actually go through the scan data and cut sections, cut those reference sections through each one. So that's way too tight. Let's open that up to, let's try 0.35. And again, this will take a minute. So now you can see we've got a section cut through each one of these, let's call them levels, so that we get a good section so we can basically see the entire part. So anytime you have a part like this that's kind of staggered, that's where you'll want to do this, okay? So we'll tell it, hey, this looks good, and we'll go ahead and cut these. We call them mesh sketches. What it does is it cuts through the scan data, and then the entity that it creates inside SolidWorks is just construction geometry. So it's like a polyline. It's just a multi-point line. But that's not really a sketch. That's not how you sketch. So you're going to see here in a second, what we're going to do next. So now that it's created this geometry, we're going to go ahead, and you can see we've got at least one section through each one of these levels. And we're going to go ahead and select that plane that we have here at the bottom. And let's get it into a top view. And let's hide now the scan data. And this just makes it easier to build our first sketch. So we're really going to take this outline of all of these cross sections at those different levels, and we're going to build now a SolidWorks sketch. Okay, so we go under our normal sketch command, and this is where you just start using SolidWorks. And we're going to go ahead and build our sketches. So you'll use lines, arcs, circles, all the normal tools. And again, this is just construction geometry now. So you're going to trace over it. You can snap to it. So now this just becomes how you like to do things. And again, this is where I am not an expert in SolidWorks, but I'm going to try to keep things simple here and just create some geometry. So let's start with a 3-point arc. And every designer does things differently from how you solid model and create your sketches, but I'll just fit some arcs. And keep in mind, I'm going to try to fit geometry through here, and at times you're going to see it's not a perfect fit. And that's because you're scanning a as manufactured part, and it may not be square or perpendicular or parallel. And also you may want to make changes to the part. You may not want to follow the design. Maybe the part is worn, or maybe you're going to design it a little bit differently. So don't think you have to follow this data exactly. So, for example, here the part slopes down or has this taper to it. Maybe I want to just make that a sharp corner. I'll go ahead and follow it in this case. And you're going to see I'm kind of sketching beyond the geometry, because I'll come back and trim that versus trying to find that corner. And we're going to come over here now, and we'll go ahead and fit another arc over here. And again, I'm just going to eyeball it. Now you can also add dimensions to this stuff, to all of this, because again, these are just SolidWorks sketches. So if this radius is, 48.492, you may decide, hey, I'm going to just make that, 48.5. So you can kind of override this. You can fit geometry and then add dimensions if you want, or add constraints like parallelism, make it perpendicular, whatever it may be. And then we'll come down here and then trim this. But this is the basic concept all the way through what you're going to see here. So the last thing we'll do now is trim up this corner. And again, I like to just, for a lot of corners, I just will do this. It's just as easy. And you can see now we have a sketch, a normal closed sketch, and it turns gray like it always does in SolidWorks. So you're, just to reiterate, we created a plane, we cut this, what we call mesh sketch, through the geometry, which is just construction lines, and we then built a real SolidWorks sketch. So let's turn all those reference sketches off except our real sketch. And now let's go ahead and turn our scan data back on, because we're going to extrude this up, and we want to take a look and determine, where do we want to extrude this up to. And we're probably going to go, there's a couple ways we could do this, all the way to the top and then trim things back, or maybe up to this blue plane right there. So what I'm going to do, the easiest thing to do to trim that is to go back into the Geomagic for SolidWorks tab, and I'm going to extract another plane, and we'll pick this blue region. And that just makes it easy. I don't have to go in and try to measure it. And I'm actually going to pick all of those areas and average it, just so I get a good average of all those planes. It's going to best fit it through those planes. So now we go back to extrude, and we're going to select our sketch, and we're going to go up to a surface, and we're going to pick this top plane, and there is our first body, or our first feature, or solid, whatever you want to call it. And that's essentially going to be the concept for this part all the way through. So we're going to have to now cut some things back, and then we're going to have to add to it. So next we'll go ahead and cut one. So, and again, you can see where you've got gray, but then you can see the scan data. So that tells you, this part is not flat. And you can see it in the scan data. You can see this is a casting. They're never perfect. They're typically machined, so they're usually cast and then machined. So they'll have machined surfaces. But it's not uncommon when we start fitting perfect geometry through a casting that you're going to see differences. Also, if there's draft, whether or not you're going to model the draft into the part. Typically, when you reverse engineer it, you're going to go back to the as designed, because maybe this part's going to get machined down the road, or cast or forged in a different method, and they'll add in the draft or whatever they need, based on their requirements. So we're going to go back to cutting one section, and we really just need this section right here, that curve, and we can then cut that away as our next feature. So back to the sketch tab, and we're going to want to pick the plane we want to start on, and I like to hide the mesh, just makes life easier. And let's get back into our top view. I like to work from the top, it just makes life. So we want to cut this circle away, and you can see we've got a few spots where there is no mesh sketch, just because maybe there wasn't some scan data in those areas, but that doesn't matter. We have enough here to fit a circle. So again, we'll just pick on here. Oops, wrong circle. Let's try that again. Or wrong type. I want to do 3 points, so we'll pick, and pick. And again, you could dimension this, and I think it said 10.32 if you want to make that 10.375 or 10.25. Again, you can override this and do really whatever you want. You don't have to follow it. Okay, so let's bring our scan data back just for reference. So we're at the bottom of the part with that sketch, And again, we want a plane right where that kind of orange color area is. So we'll extract a plane. And I like to do this because then I don't have to go in and try to measure it and figure out how thick things are. I'll just create a plane. And now we are going to do, in this case, an extrude cut. So let's bring our body back on. Extrude cut. Pick our sketch. And we want to go up to a surface. And then pick the appropriate plane that we just created. And then hit OK. So we're going to cut that area away. So we built our first sketch up, and then for our second feature, we cut back. And we'll do this then for the next circle. So we've got one more circle we've got to cut away. And this is great because you can keep going back to the mesh scan data and reference it. Once you have it scanned, you have it forever. So it really makes it easy to be able to turn on and off the solid model and look and say, okay, what do I need to model next? Which is going to be this feature here. Now for time purposes, I'm speeding this up because we're really doing the same thing again. Picking a plane, extracting the plane from the bottom, creating the cross sections, slightly below the plane so we get it right there in the scan data. Okay, we want to always get below those radiuses, and then we're going to create our sketch. So turn off the mesh data, go to the top view, and come in here. And I struggled a little bit with trying to trim this because I don't know some of the trimming commands well in SolidWorks. I finally kind of figured it out. Now here I'm just drawing outside the part, and so we can draw it kind of all the way around, because it doesn't matter beyond the circle in this area because you're out beyond the part, so really doesn't matter. And that way we can we can trim this away. So I noticed over here I hadn't trimmed that correctly or followed it, and that's one nice thing. You always have that mesh data to rely on and look at it and make changes as you go along. So once we get our sketch the way we want it, in this case we'll just go blind because we don't really care as long as it's beyond the bottom of the part, and we'll just trim that up, and that's it. All right, we're going to speed it up again to go through the next feature here because it's really similar to the last two we did. We want to cut this kind of big area here away from the part and cut that off. And so again, we build a plane. Now, you notice this region group curls over that edge. So in this case, I'm just going to manually draw an area and extract a plane. You don't have to use region groups. You can pick points or just use the lasso tool, select some scan data, and fit a plane through that. So that's what we did there. We're cutting our section. Again, we want to bump it up. This radius is a little bit bigger, and get it up. You always want to try to get off that radius and get on that vertical wall, or away from that radius. This wall has a little bit of draft to it, but close enough. So we're going to go ahead and build that feature and then just cut that out, just like we did before. So again, just using a lot of the arc commands, and then we're going to just draw a line again out in space off the part. Here we'll use the fillet command, and then we'll extrude. This will be a cut because we're going to want to cut this one away, and there we go. Okay, so this next sketch is going to be the most complicated, and it's really going to be this, as you see here, kind of all the way around this geometry here, kind of these, I guess we call them ribs. So it's not difficult. It's just, takes a little bit of time to just kind of draw it out. It's just, now one thing you can do too is draw the corners as sharp corners, and then once you have a 3D model, you can add the radius in. I tend to add the larger radiuses in, and the smaller ones I'll wait to once I have the whole thing as a solid model, and then add those in as fillets. But it's really personal choice. Here I'm also using the convert entities command to extract the edges of the existing solid body so that things line up. and trying to make everything parallel and perpendicular. I'm not driving this with dimensions. You could do it, but just for time, I won't. But again, this is normal sketching, and if you want to add the dimensions to it, you can do it. But you can see it takes a little bit to make sure I have a completely closed profile here or sketch so that I can extrude it. Obviously, you can't extrude it if it's not closed, so I had to run this command here because I found one area I didn't have. And then we go ahead and extrude it up, and we created a plane at the top already, so we have that, and there we go. All right, so next up is just a few more cutaways, and again, we'll speed this up. We've got a few circles to cut out and a couple other features, but we're just going to kind of, again, because this becomes very repetitious, but we'll go ahead and speed this up so you can watch it. So we need to cut, just cut this little piece out here on the end. So we'll come in here, same thing, draw our plane, just kind of make a basic sketch, extrude this one up. We'll do a blind extrude cut that away. Now we'll come over here, and what we just did there is an accuracy analyzer. We can compare the scan data to the CAD data and just see how we're doing. It's never going to be perfect, again, because we're modeling things as they're perfect. Obviously the scan data isn't. Now this is not a circle. It may be like an oval, and you might be able to use an oval command. I just used the spline command and drew some points around for this, but however you want to do it. Again, it doesn't matter. If you give this part to two different engineers, they may both have two different methods of doing it, but at the end of the day, if it's correct, it doesn't really matter your method so much. Here we're going to cut out the hole in the bottom and then this slot itself. And again, we're just going to fit a circle. We'll do that one first, extrude it up and down as a cut. And then finally, we'll trim away this kind of wall here. And again, I turn the mesh on and off. I like to usually create my sketches with the mesh turned off, but then compare it. Sometimes I have to turn it back on. Like you see here, I thought that it kind of notched over, but then when I looked at the actual wall itself, it's not, it's straight. So I went and deleted that and then just trimmed it up. So it is nice to kind of reference the scan data. And again, I just cut that away. And here I'm just hiding some of the data, kind of taking a final look. We'll run that accuracy analyzer again. Overall looks pretty good. So, to model this part, if you're pretty proficient in the software, it should take you about an hour to model this part. So pretty quick when you consider how many features. There's a few more holes and some radiuses and fillets. I'm not going to show all of that, but you get the general idea. But somebody that knows SolidWorks well, it's very easy to pick up Geomagic for SolidWorks. You could model this part in about an hour, which if you had to do it through traditional methods, I would think would take much longer than that. And we know this is going to be very accurate because the scan data was very accurate. But just a brief overview of Geomagic for SolidWorks.